So in this short video I'm going to talk about virtual functions, and they are the backbone of polymorphism. So just to keep it simple, I'm just going to review what we have done so far. There is a person class, and the person class has constructors and some accessor and mutator methods, and then there is a function called print, and the signature or the header of the print function, it's a void function, and it's a const function, which means it's not going to change the object which is going to call this function. Now there is a class student which is also which is derived from class person, and so this is person is the base class or the super class, and student is the derived class or the subclass. And we have we have a few constructors and some accessor methods in student class, but we also have a print function of student class itself. The difference in the definition, how the implementation of the print is that the person print class only prints the ID and name because they belong to class person, and in student class we have added two more attributes, GP and major. So the print function of student class calls the print function of the base class, which prints ID and name, and then also prints the student's GPA and major. So the student class's print function does some extra work. And now last time in the previous video we have discussed about downcasting and upcasting. So I'm reusing this example where we create a student object with 4 argument constructor. We pass the ID is 5, name is Christina, GPA is 3.5, and major is ECE. And then we created a pointer to person object. That means that we can point, this pointer can point to any object of class person. Now what we did is, because we have a class, what we have actually is an object of student class, and since the student class is derived from class person, it is legal, it is okay that the person pointer is actually pointing to a student object. This is called upcasting, because the pointer of a base class is pointing to an object of the derived class. So in one sense we are converting or casting from a derived class object to a base class, and then we call print. Now we know that if we run it, this program builds, of course there are some warnings, we have talked about these warnings, and then when we run you can see that the person class print function is called, and the print function is going to print the person's ID and name. Although the object is of type student, the pointer is of type person, and since the person class the pointer is of person class or person type, the print function of the base class or the person class is called, because the base class has no idea about what the derived classes are doing and what methods and what attributes are available in the derived class. Now this can be limiting in some places where we want more specific information, but the specific information is there in the student object but we don't have access, and that's where virtual functions come into play. Remember, this is important. So we will add a keyword virtual to this function in class person. Very important that we are adding the keyword virtual in the base class, not the derived class. It's not required to add virtual in the definition of the derived class, but I will add virtual here, and as you see, as soon as I add virtual, the print function changes to italics. Of course that's done by the Qt creator. The IDE is helping us recognize that this function is a virtual function, and only this one keyword has an implication. The implication is when we call print, the person pointer is actually pointing to the student object. So because the print function is virtual in the base class, compiler tries to see if the person pointer is pointing to a person object or another derived class object. And if there is a definition of the same function in the derived class, then this print function is actually going to invoke the method from the derived class instead of the method from the base class. And for this purpose, the compiler keeps a vtable. So sometimes you will see errors in vtable when things get messy, but vtable error usually means that the compiler is not clear that whether the pointer is pointing to an object of the base class or a derived class. But vtable is maintained to keep track of that this is an object, pointer of type person, but it is actually pointing to a derived class object, which is a student class. And when we call a virtual function, then the compiler looks into the derived classes and see if there is a function of the same definition in the derived class, and it will call the function from the derived class, not the base class. And for that, again, just a reminder, we have to add virtual to the function in the base class. And you can see here I have not added virtual to the derived class. It's not required. It will not hurt even if we do that, because that will help later on if we use a student as a base class for another class, then that will be helpful, but for now it's not. So now if I run this code, so the only thing we changed is we added virtual to the base class print method, and now when I run, you can see here the print function on line 12 is calling the print method of the derived class student, because you can see the student GPA and major is also printed. So that's about virtual functions. Now how are they useful? They are useful. I'll give you an example in the next video. That let's say if we have multiple classes, for example this faculty class which we introduced earlier, we didn't really write any code to keep things simple, but this faculty class also is deriving from class person. So now if we have objects of we have pointer of class person, it could point to an object of student class or a faculty class. And if both of them have print function, both student and faculty classes have print functions, we could call print function, and because it's a virtual function, the actual function that is executed will be the one of the derived class, that is a student or faculty. That way we can call specific methods that belong to a more specific classes using a base class, a common base class, and that's called polymorphism, and that's very important concept. So we will see that later.